Right now, as you listen to this, you are technically sitting in complete darkness.
Yep. It's a wild thought.
I mean, the vibrant room around you, the colors on your phone screen, the light coming through the window, your eyes aren't actually seeing any of it.
Right.
Your brain is actively hallucinating this entire reality based on like a continuous stream of raw electrical pulses being beamed from the back of your eyes. So, welcome to the deep dive.
It really is a wild concept to start with, but I think it perfectly frames what we are unpacking today.
Oh,
We tend to think of our eyes as mere windows, right? Just passively letting light in.
like a camera lens.
Exactly, just an open window.
Yeah.
But biologically, there are these hyperactive, incredibly demanding extensions of the brain itself.
And that is the core mission for today's deep dive. We are pulling from this really fascinating research in Visium Plus and the science of healthy vision to give you, the listener, a shortcut to understanding the hidden mechanics of your eyesight.
Yeah, we're definitely skipping the basic middle school biology lesson today.
Thank goodness. We are looking straight at the metabolic engine of your vision. You know, why our modern screens are stressing that engine to the breaking point, and the specific science behind how you can actively protect it over a lifetime.
So to understand the wear and tear on this system, we really have to look at the sheer speed of the data processing involved. It's less like a simple biological assembly line and much more like a high-frequency trading server.
Okay, let's unpack this assembly line idea because the speed is crazy. So light hits the cornea,
Right. It hits the cornea, gets metered by the pupil,
focused by the lens.
yep, and strikes the retina in literal milliseconds. And then the optic nerve has to carry that massive data payload straight to the brain.
The precision required for that pipeline to function is just staggering to me. If there is like a microsecond delay or a slight clouding in the lens or a microvascular bottleneck in the optic nerve, the entire system just degrades.
Yeah, and you experience that mechanical failure as blurriness or tension headaches or just general eye strain.
Which brings up the metabolic cost of running that server. Because you don't turn your eyes off until you go to sleep, the physical structures inside the eye are under immense continuous stress.
Absolutely. Take the retina, for example. It is packed with millions of photoreceptors. You've got your rods for low light.
And cones for the high-definition color.
Exactly. And converting physical light into electricity millions of times a second takes a massive amount of fuel. The retina is actually one of the most energy-hungry tissues in the entire human body.
Wow.
It consumes massive amounts of oxygen just to keep that whole conversion process running.
Wait, hold on. Oxygen is generally the good stuff, right?
Yeah.
We breathe to get oxygen to our tissues. How is burning oxygen a vulnerability here?
Well, think of a combustion engine. It burns fuel and oxygen to move the car forward, but that process inevitably produces exhaust.
Oh, sure.
In the retina, when cells burn oxygen at that extreme continuous rate, they generate a chemical byproduct. We call these free radicals.
Right, I've heard that term.
Yeah, they are highly unstable molecules that are essentially missing an electron. Because they are unstable, they desperately try to steal an electron from anywhere they can find one.
Like little microscopic thieves.
Exactly. And usually they do this by ripping an electron away from the healthy cell walls and delicate nerve tissue immediately surrounding them.
So they are basically microscopic wrecking balls tearing up the retina just to stabilize themselves. That is a fascinating paradox. The oxygen required to power our vision is simultaneously producing the exhaust that threatens to destroy it.
It is the ultimate biological catch-22. That continuous microscopic damage is what we call oxidative stress. And it's the primary reason our vision degrades as we age.
Wow.
But here's the thing. While the retina is fighting off those free radicals with the robust blood supply it has, there is another crucial structure in the eye that doesn't even have that luxury.
The lens.
Yes, the lens.
Its main job is accommodation, right? Flexing and changing its physical shape to focus light from varying distances. But there was a detail in the research that made me stop and reread the paragraph completely.
It's shocking, isn't it?
It really is. The source says the lens has absolutely zero blood vessels. None. I mean, if I cut off the blood supply to my finger, the tissue dies. How does a living, flexing tissue inside the eye survive with no direct blood flow?
It is an incredible evolutionary trade-off. Think about it. Blood vessels are naturally opaque.
Right, they're red and thick.
If you had a network of red capillaries running right through your lens, you'd be looking through a dense red web all day long.
Oh, that sounds awful.
Yeah, it wouldn't work. So to remain perfectly transparent, the lens had to evolve without a direct blood supply. It is forced to pull all its nutrients and expel all its waste through the clear fluids that are just slowly circulating around it in the eye.
Okay, I understand the necessity of it being clear, but that leaves it incredibly exposed. I mean, if those free radicals we just talked about get into the lens, there's no fast-flowing blood to quickly flush them out.
The vulnerability is immense. The lens is constructed of highly organized, densely packed proteins called crystallins,
Crystallins, right?
and their sole purpose is to stay perfectly aligned so light passes through them like clear glass. But when free radicals bounce around in that bloodless environment, they damage those proteins.
And what happens when they get damaged?
The damaged crystallins start to clump together. When they clump, they lose their transparency and become cloudy. This is the exact mechanism behind how cataracts form.
Wait, really? That's what a cataract is?
Yep, it's just accumulated oxidative damage to transparent proteins that lack the blood flow to defend themselves.
That is wild. But if the lens sacrificed its own blood supply to stay clear, the surrounding tissues, like the ones generating those clear fluids, they must be working overtime to compensate.
Oh, they absolutely are. If we connect this to the bigger picture, the vascular network supporting the eye is incredibly dense to make up for it, but it's made up entirely of microvessels.
Just tiny capillaries.
Right, capillaries so remarkably thin that red blood cells sometimes have to bend just to travel through them, single file.
Wow, single file.
Yeah. And this microscopic network is why your systemic heart health is deeply, inextricably linked to your eye health.
So if someone has high blood pressure or just poor general circulation, their eyes take the hit early because those specific vessels are so tiny and fragile.
Exactly. They are some of the most sensitive indicators of vascular health in your body. If your circulation is sluggish, the retina doesn't get the oxygen it needs to fuel its photoreceptors.
Which means it can't run the engine.
Right. But more importantly, it can't efficiently wash away the free radical exhaust it's constantly producing. So the waste just builds up.
And that exhaust buildup directly threatens the next station in the pipeline, which is the optic nerve. I always envision the optic nerve as just a passive tube, but the research frames it as a highly compressed data cable.
It is a compressed bundle of over 1 million individual nerve fibers. The eye takes in an overwhelming, chaotic amount of raw light data. The optic nerve's job is to compress and transmit that data into electrical signals that the brain's visual cortex can actually process.
Okay, so if the micronestles feeding the optic nerve are damaged by oxidative stress or poor circulation, what happens?
Those individual nerve fibers start to suffocate and die off. You literally lose data in transit.
The signal to the brain degrades.
Exactly.
Which brings us to the modern environment. Here's where it gets really interesting, because it feels like we've engineered a lifestyle specifically designed to put maximum strain on this delicate system.
We really have.
We are forcing our eyes to work in conditions they simply did not evolve to handle.
The ambient modern environment is a massive accelerator of the oxidative stress we've been outlining.
Yeah. Beyond the normal metabolic exhaust our eyes produce just by being awake, we have UV radiation from the sun, indoor environmental pollution, and, well, the undeniable reality of blue light.
Blue light is a huge factor.
Most of us are staring at phones, laptops, and televisions for 10 to 12 hours a day. All of these external factors are actively bombarding the eye and generating additional free radicals.
But biology does have a built-in defense mechanism against this environmental barrage. It comes down to a term we hear constantly in food marketing, but rarely understand mechanically: antioxidants.
Yes, let's actually define that, because antioxidant is usually just slapped on a bottle of juice to make us feel healthy. What is an antioxidant physically doing inside my retina when I consume it?
Okay, so recall that a free radical is an unstable molecule desperately looking to steal an electron from your healthy cells.
It's a little wrecking ball.
Right. An antioxidant is essentially a biological philanthropist. It carries extra electrons and willingly donates them to the free radicals.
Oh, that's incredibly efficient.
It really is.
Yeah.
By giving up an electron, the antioxidant neutralizes the wrecking ball before it can smash into a retinal cell or clump a lens protein. And the elegant part of this chemistry is that the antioxidant remains completely stable even after donating its electron.
That completely shifts how I view nutrition. I'm not just eating healthy food. I am actively restocking an armory of electron donors.
That's the perfect way to look at it.
The text details specific compounds that are highly effective at this inside the eye, like vitamin C, vitamin E, zinc, and selenium. But then it gets into more complex plant compounds like carotenoids, polyphenols, and flavonoids.
Those complex compounds are the heavy hitters for eye health. Take carotenoids, specifically lutein and zeaxanthin.
I see those on supplement labels all the time.
Right, and when you consume them, they actually migrate to the retina and accumulate there, acting like a pair of internal sunglasses.
Internal sunglasses, that's amazing.
Yeah, they physically absorb the high-energy blue light from our screens before that light can even trigger the creation of free radicals.
Wow.
And then you have polyphenols and flavonoids, which you find in brightly colored fruits and vegetables. They are massive electron donors that keep the microvascular system flexible so blood flows efficiently.
The biological blueprint makes perfect sense. Our eyes are under constant metabolic and environmental stress, and they require a continuous supply of these electron donors to prevent structural damage. But looking at the reality of how most of us live there is a massive disconnect.
A huge disconnect.
Yeah.
The modern routine creates a severe nutritional gap.
So what does this all mean for you, the listener? I mean, we might grab a salad occasionally, but primarily we eat for convenience. Our diets are heavily processed, and we are not consistently getting the selenium, the lutein, or the specific flavonoids our retina is required to fight off a 12-hour screen session.
And the critical issue is that the eyes do not get days off.
Right.
If there is deficit of antioxidants on a Tuesday, the free radicals generated from staring at your spreadsheets all day go completely unchecked. The structural damage to the lens and retina is cumulative.
This is exactly where targeted supplementation enters the conversation. The research details a specific formulation called Visium Plus, designed for adults actively trying to bridge this exact nutritional gap.
Yeah, it pulls together the heavily researched nutrients we just explored into a daily baseline.
It is formulated to ensure the body has a consistent inventory of electron donors. It includes the standard vitamins and minerals, but what is particularly noteworthy from a scientific perspective is the inclusion of specific plant extracts and mushrooms.
I'm glad you brought up the mushrooms because that jumped off the page for me too. We hear about vitamins for eye health constantly, but why are mushrooms suddenly relevant to my vision? Well, certain botanical extracts in mushrooms function as adaptogens.
Adaptogens, okay.
Instead of just donating electron like a traditional antioxidant, adaptogens interact with the cells to help modulate the body's overall response to stress.
So they work differently than the antioxidants.
Exactly. In the highly stressed, high-oxygen environment of the retina, adaptogenic compounds help the cells maintain homeostasis, basically biological balance, even when they are being relentlessly bombarded by blue light.
That is fascinating.
It is a fascinating area of emerging research focusing on supporting the resilience of the cell itself, rather than just neutralizing the external threats.
It is a highly sophisticated approach to cellular health. However, the research materials make a very distinct point about how to view a supplement like this, and we need to be crystal clear about it. Swallowing a capsule of Visium Plus does not grant you a magical force field that lets you stare at a monitor for 18 hours straight in a dark room while eating junk food.
This raises an important question about how we view supplements in general. A supplement is designed to complement a healthy biological baseline. It cannot overwrite a chronically destructive lifestyle.
Exactly.
You still have to manage your physical environment and your behavioral habits.
Let's cover that physical management, because there are actionable habits that immediately relieve the mechanical stress on the eye. We know we need to incorporate more leafy greens and berries for the polyphenols.
Right.
We know we should wear UV-blocking sunglasses to physically stop solar radiation before it hits the cornea. But for digital eye strain, the fatigue from looking at laptops and phones there is the 20-20-20 rule. And with our new understanding of how the lens works, this rule makes total mechanical sense.
It remains the most effective behavioral intervention for anyone working in a digital environment. Every 20 minutes, you look at something at least 20 feet away for a minimum of 20 seconds.
Mechanically speaking, why does a mere 20-second break matter so much to the lens?
When you focus on something close up, like the phone in your hand right now, the tiny ciliary muscles surrounding the lens have to contract.
Okay.
They hold strict tension to keep the lens flexed and focused on that near object.
Yeah.
Imagine holding a heavy dumbbell at a 90-degree angle for 3 hours.
Oh, your bicep would be screaming.
Exactly. That sustained tension is exactly what you are doing to your ciliary muscles when you stare at a screen. Looking 20 feet away allows those muscles to completely release and flatten the lens.
And it takes 20 seconds.
20 seconds is the absolute minimum time required for those muscle fibers to actually reset.
You are literally telling the eye to put the dumbbell down for a moment.
It prevents the structural spasm that causes tension headaches and blurred vision at the end of a long workday, When you combine that mechanical relief with proper hydration to maintain the tear film
Which is super important.
and regular eye exams to monitor those delicate microvessels, plus a consistent, robust intake of antioxidants, you create a highly effective, comprehensive defense strategy.
It comes down to realizing that your vision is an active daily investment. It requires a cooperative effort from your oxygen-guzzling retina, your bloodless lens, your microvascular system, and the habits you maintain to keep them fueled and protected.
Once you understand the sheer metabolic cost of seeing, you really start to treat your visual system with the respect it demands. It is a masterpiece of biological engineering that requires deliberate, constant upkeep.
And the stakes of that upkeep are profound. Think back to where we started today. Your brain is sitting in a dark, silent vault inside your skull, actively generating the colors, the faces, and the landscapes of your reality based entirely on the raw electrical signals it receives from your optic nerve.
It's all constructed in the dark.
Exactly. The fidelity of your entire reality, how crisp, how vibrant, how clear the world appears to you, is entirely dependent on the health of that microscopic machinery. When you protect your eyes with the right nutrients and habits, you aren't just saving your vision, you are preserving the very interface through which you experience the universe.
Beautifully said.
Something to think about the next time you reach for your sunglasses or take a screen break. Thank you for joining us on this deep dive. Give your eyes that 20-second break today, and we'll catch you next time.